Okay, so now we're going to look at the addition rule. So in 3-2, we learned how to find the probability of two events occurring in sequence, denoted the probability of A and B. In this section, we're going to look at how to find the probability that at least one of two events occur. So the probability of A or B, and depend on where the events are mutually exclusive. So first we need to know what mutually exclusive means. And this is when two events A and B cannot occur at the same time. Okay, so you have a picture here that shows you that the one on the left, A and B, there's no overlap. So those probabilities are separate, so they are mutually exclusive. Looking at the one on the right, there's some overlap of when A and B occurs, and we'll talk about what that looks like because it's going to affect how we find our probability. So, looking at our examples, decide if the events are mutually exclusive. Explain your reasoning. So our first one, we have event A is roll a 3 on a die, and event B, roll a 4 on the die. So if we roll a die once, can those two events occur at the same time? No. So that means they are mutually exclusive. Because you cannot roll a 3 and a 4 at the same time on one die. Okay. So looking at 2 and 3, I want you to try those and we'll talk about them in class. Then we have our addition rule for the probability of A or B. So this is where that mutually exclusive comes into play. So the probability that events A or B will occur, which would be the probability of A or B, is given by the formula the probability of A or B equals the probability of A plus the probability of B minus the probability of A and B. Okay. If the two events are mutually exclusive, then the rule can be simplified to the probability of A or B equals simply the probability of A plus the probability of B. Okay, so if we go back up and look at this picture of mutually exclusive, notice that when those two circles overlap, that means that they're listed twice. So that's why we have to subtract one of them because we don't want to double that amount. All right, so looking at this first example, you select a card from a standard deck. Find the probability that the card is a 4 or an ace. So can a card be both a 4 or an ace? The answer is no. It means they are mutually exclusive. So how many 4s are in a deck of cards? There's 4 out of the 52 cards. How many aces are there? Again, there's 4 out of the 52, which leaves us 8 over 52, which we divide, and we get 0.154. Okay, you roll a die. Find the probability of rolling a number less than 3 or rolling an odd number. So if we're less than 3, that would be a 1 or a 2. And if we're an odd number, that's a 1, 3, or 5. Okay. less than 3, or odd. Okay, so less than 3, we had 2 options out of the 6, plus odd, we have 3 out of the 6, and then we're going to subtract the overlap. Okay, there's one thing that we have counted twice, so subtract the 1 over 6. 2 plus 3 is 5, minus 1 is 4. So 4/6, which is approximately 0.667, or 2/3. All right, I want you to try this next example, and then we will also go over using the empirical rule in class next time. And then we'll finish up this summary. Okay, this table is a great resource for you, okay, as it includes just about everything we've talked about for probability. Okay, so use that to help you when you're completing your homework.